Hello everyone, how are you all? Welcome to Deeksha Karnataka YouTube channel. I hope I am audible. Hi Alan, hi Vinod, hi Manjunath, hi Madhvi. I hope everyone is doing well. Right, Aishwarya, good evening. So today I am going to discuss a very important chapter of your KCET preparation, which is electrostatic potential and capacitance. Usually 3 to 4 questions on an average do comes from this chapter, right? Right, now let's first, before starting this session, I would like to tell you one thing, that in this lecture I am going to use last 20 years PYQ book, Karnataka CET, okay, published from Deeksha Vedantu. If you want this book, you can click on the link in the description and download it. Now the first question is from page number 101 and question number 61. So let's see. Under the electrostatic condition of a charged conductor, which amongst the following statement is true? So you have to find the true statement. That means 3 of them are false, only 1 is true, right? 3 of them are false, only 1 is true. Let's see the options. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught, where sigma is the surface charge density. The electric potential inside a charged conductor is always 0. Any excess charge resides on the surface of the conductor. Net electric field is tangential to the surface of the conductor. Now let's see which option is correct. Madhvi is saying option C, Manjunath option C, Alan is saying C, Vinod is also saying C. So any excess charge resides on the surface of the conductor. Yes, this is the only correct statement. Those who wonder why these statements are not correct, so first of all, for a surface charge density of a conductor is given by sigma by epsilon naught, not sigma by 2 epsilon naught. Now electric potential inside the conductor is constant, not 0, so this is also incorrect. And net electric field is not tangential, it is perpendicular, right? It is perpendicular to the tangent, so it is perpendicular to the surface, so this is also incorrect. Only correct statement is this one. Next question is from again page number 101 and question number 59. Very interesting question. A uniform electric field vector E exists along the horizontal direction as shown. The electric potential at A is VA. A small point charge Q is slowly taken from A to B along the curved path as shown in the potential energy of the charge when it is at point B is. So basically what you have to calculate is that the charge is taken from A to B via this curved path, okay, and you have to calculate the potential energy of the charge when it is kept at B. So potential energy, by the way, if you want to get this book, you can scan this QR code from your mobile and you can get the book, okay. Now potential energy is basically given by Q into the potential at that point. So potential at VB, if it is given, then it would have been just a single line question, okay, Q into VB, but VB is not given, VA is given, okay. And what else is given? It is given the electric field is given in the direction, okay. The direction of electric field is also given in this particular direction, okay. Now you have to understand that the curved path is just given as a distraction. It does not matter. Only thing that matters is the shortest path between the 2 points. Shortest path between the 2 points, because electrostatic field is a conservative field. So this distance is important. Now let's see who can answer this question. So Vinod is saying option C for this question. Manjunath is saying 2D. Vinod changed his opinion, saying option A. Madhavi is saying D. Alan is saying D. Okay, let's see. Very interesting question. So first of all, you have to understand that as you are moving in the direction of electric field, the electrostatic potential decreases. So VV must be less than VA. Okay, so VB must be less than that of VA, right? Now what is the value of potential at B? So you can use the formula which is given by electric field E is given by minus dV by dx, okay, or minus potential at the final point minus potential at the initial point divided by x, okay. So from there you can say that, okay, this means E into x must be equals to minus VV plus VA, okay, or VB equals to VA minus EX. So this is the potential. So we have calculated the potential, just multiply it. So it will be VA minus EX. This is the electrostatic potential energy at B. So correct answer is option D. Okay, those who answered option B or option A is obviously not correct. Option B is not correct. So because you have to understand that because you are moving in the direction of electric field, the potential will decrease, and potential decreases means it must be less than that of VA. So that's why VA minus EX is the correct answer. Okay, even if you want to guess the answer without doing the mathematics, you don't know the mathematics, you forget how to solve it, you just need to remember that as you are moving in the direction of electric field, the potential must decrease. So that means VB must be less than that of VA. That means VA minus EX is the correct answer. Okay, Madhavi and Alan, both of you are congratulations. Unsaid words saying yes. So now let's move on to the next question. A parallel plate capacitor of capacitance C1 with a dielectric slab between its plates is connected to a battery. It has a potential difference V1 across the plates. When the dielectric is removed, the potential difference the capacitance and potential difference are C2 and V2 respectively. Then what is the relation? Okay, so first of all you have to understand that initially there was a dielectric between the capacitor plates. Initially there was a dielectric between the plates, but after that you have removed the dielectric. So initially the capacitance was C1, potential was V1, and finally the capacitance is C2 and potential is V2. Okay, now in this both cases one thing is constant, that is charge, because charge is constant for a given system as long as it's an isolated system. For once the capacitor is charged, it is disconnected, that means it's an isolated system. So total charge is always conserved for an isolated system, no matter what, be it a capacitor, be it a simple solid sphere. So total charge has to be conserved, so that means the charge has to be Q. Okay, so if the charge is Q, that means from the first expression we can say Q equals to C1 V1, and from the second expression Q is equal to C2 V2. Now we know that if you add a dielectric, its capacitance increases by K times. K is the dielectric constant. So definitely from there we can say that C2 must decrease. C2 must decrease. That means C2 must be less than that of C1. Now in this problem there is a small mistake. Here everything will be C2. Okay, everything will be C2. This ones will be C2. Okay. Right? Okay. Now let's see. Let's see the answer. Someone is saying option C. Manjuna is saying option 3C. Binod 3B. Maitri joined. She is saying 3B. Madhavi is saying 3B. Alan is saying B. Madhavi is again saying B. Okay. Manjuna is saying is 3C. Let's see. So capacitance decreases. So capacitance decreases, but charge remains constant. So only thing that can happen is that potential will increase. That means C1 must be greater than that of C2 and V1 must be less than that of V2. So this is the only possible combination. So capacitance decreases, potential increases, so that overall the charge remains constant. Okay, so potential, someone is saying option D is not correct because V1 cannot be equals to V2, definitely not. So let's see the correct answer. So V1 is less than V2 and C1 is greater than C2. So option B is correct answer. So option B is correct answer. So Vinod, Maitri, Madhvi, Alan, everyone is correct. Manjunath, check your answer. It will not be C. So C means V1 equals to V2, which is not correct. Okay, V1 has to reduce so that the total charge remains constant. Okay, see, if one quantity is multiplication of two quantities, this quantity remains constant, one of them is decreasing, that means the other quantity has to increase to keep the balance, right? Now, if you want to download the PDF of this lecture along with the notes, then definitely you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description section of this video, and obviously also you have to subscribe to our channel if you have not yet subscribed. If you are watching without subscription, please subscribe to our channel, and then you will be able to chat in the chat section, right? Only subscribers are allowed to chat in the live chat. So subscribe to our channel and join the WhatsApp channel. WhatsApp channel link is also given in the description. There you will get all the updates, all new things, new features that we are doing, right? And also let's continue. The electric field and the potential of an electric dipole along its axis vary with distance molar respectively as. So how the potential and electric field. So first is electric field, second is potential. How they vary for a dipole. Okay, so this is the important concept. Electric field, electric potential, electric dipole. Very easy question. So don't think too much, answer it directly. Madhavi is saying question 4 option D. Check again, it is electric dipole, not single charge. So electric dipole, electric field and potential. Aishwarya Kamath is saying option A, Oreki is saying 4C, Manjunath is saying 4C, Madhavi already answered, Maitri option C, Vinod option A. Okay, so for a dipole, electric field, suppose we are taking the axial case dipole. For an electric dipole, for an axial case, it is given by 2p divided by r cube. Obviously 1 by 4 pi epsilon naught is there. Okay, so 2p by r cube is the axial case. So as you can see, and in case of equatorial plane also, it is minus 1 by 4 pi epsilon naught p by r cube. So in general equation also, if you see the general equation, in all cases it is always axial electric field due to a dipole is always proportional to 1 by r cube, and electric potential, if you calculate, potential is always p cos theta divided by r square, so it is proportional to 1 by r square. So potential is proportional to r square, electric field is proportional to r cube. So option C is correct. Madhavi, please check your option. I think she corrected after answering a wrong first time. Sir, blueprint. Blueprint for 2025 is not yet available. Okay, they took one closed review of question bank for 2025, which is only for the teachers, those who are teaching in the government schools. It was available till 25th October, but right now it is also not available. So once they release any new blueprint, we will definitely discuss it, and definitely we will be the first one to check that and update it. Okay, blueprint for 2025 is not yet available, right, Nikhil? Madho, this is Sankalp series only, Madho. Okay, Madho. Yes, Madhavi, because it's a dipole, that's why it will be option C. It's a point charge. Then your answer option D was correct. Two tiny spheres carrying a charge 1.8 microcoulomb and 2.8 microcoulombs are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges is. So this question came in 2022, and if you go to this book, this question is on page number 101, question number 56. So we have two spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb. Okay, their distance is 40 centimeter, and the potential at the midpoint of the line joining the two charges is, so potential at the midpoint of the line joining two charges, say this is P. Now what is the distance? This will be 20, this will also be 20. So both charges are at a distance 20 centimeter from each other. So what is electric potential? Now potential, remember one thing, electric field is a vector quantity, so you need to consider the direction, but for potential it's a scalar quantity, so you don't need to consider the direction, only magnitude is sufficient. Also, while calculating potential, if one of the charge is negative, you have to use negative charge. Generally for electric field, we do not take the sign of the charge, we only take the direction of electric field. So this is very, very important point to understand. Okay, for electric field we take the direction according to the sign of the charge, but we do not put the negative sign inside the equation. But in case of electric potential, if negative charge is there, you have to take the negative sign. In this case both of them are positive, so potential, say this is point charge number 1, this is charge number 2, so potential due to 1 is given by K Q1 by R, and potential V2 is equal to K Q2 by R. Now both of them are R, and R equals to 20 centimeter, that is 20 into 10 to the power of minus 2 meters. Okay, here this is the R. So total potential must be equals to V1 plus V2. So you take K by R common. So this is the shortest way to solve such questions. Do not put the values at the beginning, try to put it at the end. So K value is given, obviously not given, but we know K is equal to 9 into 10 to the power of 9. R value is 2 into 10 to the power of minus 2. Okay, and not square, this is a potential, so don't make that mistakes as well. Now charges are 1.8 plus 2.8, that is 4.6. So it will be 1.8 plus 2.8 will be 4.6. Now cancel it, you will get 2.3. 2.3 into 9 means 18, 2 9s are 18, and 3 9s are 27, 2.7. So it will be 20.7 into 10 to the power of 11. 20.7 into 10 to the power of, oh okay, I made a mistake. Charges are given in microcoulomb, so that also has to be included. So that means it will be 10 to the power of minus 6. Okay, 10 to the power of minus 6. Right? So it will be 3.5. 2. So it will be 2.3 into 10 to the power of, so answer is 20.7 into 10 to the power of, have I made any mistake? This is 20 centimeter. So this will be 10 to the power of minus 1. Okay, 20 centimeter can be written as 2 into 10 to the power of minus 1. Okay, so it will be 10 to the power of 4. That means approximately you can take this as 2.1 into 10 to the power of 5. So I can remove one decimal point. So correct answer is option D. Let's see. 5D, sir, blueprint is out now, Madhavi. Okay, I will check, Madhavi. 2024 I have checked your official DUPE website. After let me complete this lecture. Okay, once this lecture is over, in this live session only I will go to your DUPE website and I will check if it is available or not, because when I checked they are showing 2024 blueprint, not 2025 blueprint. Okay, if it is available, definitely we will do it as soon as possible. Okay, now next, a parallel plate capacitor is charged by connecting a 2-volt battery across it. It is then disconnected from the battery and a glass slab is introduced between the plates. Which of the following pairs quantities decrease? Which of the following pair of quantities decrease? Here the problem is inverse of the problem that we have solved. So first of all, here we have a parallel plate capacitor and it is charged by a battery of 2 volts. So final potential definitely will be 2 volt. Now the battery is disconnected and then we insert a glass slab between the plates. Now we insert a glass slab between the plates. So initial capacitance is C1, next capacitance is C2. Suppose the dielectric constant is K, then C2 must be equals to K into C1. So we can see that capacitance increases instead of decreasing, so capacitance increases. And as we know that charge in the capacitor will remain same, charge will not change. So definitely charge and capacitance, any combination including charge and capacitance will be wrong. So this is wrong, this is wrong, this is wrong. So only thing that changes is potential difference and energy stored, they are decreasing. So if you have any doubt, as I mentioned, capacitance increases means potential has to decrease. So if one quantity is increasing, the other quantity will decrease because the third quantity is constant. So in this case capacitance is increasing, so potential must decrease, and potential decrease also it will reflect in the energy stored, because energy stored is given by half Q into V. Now Q is constant, V is decreasing, that means potential energy will also decrease. So option D is correct for this question. Can you hear me now? If you can still hear me, Nikhil. Mado, we will do it one by one. Okay, we are doing we have restarted the series, so that's why we started from the beginning. We will do one by one, don't worry about it. Okay, all the chapters will be done. Manjunath, Madhavi, everyone is saying option D. Vinod, Maitri, Alina is saying, sir, why I am not able to view any lecture today? So today there is no lecture in KC90. Thursday and Wednesday there are no lectures. Wednesday there was live, right? All the teachers take the live classes. Today there is no lecture. Tomorrow onwards there will be lectures again. Okay, tomorrow will be bio lecture, Friday will be Saturday will be physics lecture, and you got the schedule from there on. Okay, Alina, not Alina. Yeah, Alina, I hope that your doubt is cleared. Today there is no lecture. If you are not able to see previous lectures, please mail your queries to study@deekshalearning.com. Okay, study@deekshalearning.com. We'll definitely look into it. But today there is no lecture in KC90. We are not giving lectures every day. Okay, we are maintaining 2 days break, Wednesday and Thursday. Wednesday is live and Thursday is a rest day. Okay. Friday onwards, Friday till Tuesday, you will get lectures every day. If a slab in insulating material 4 into 10 to the power of minus 3 meter thick is introduced between the plates of a parallel plate capacitor, the separation between the plates has to be increased by 3.5 into 10 to the power of minus 3 meters to restore the capacity of the original value. The dielectric constant of the material will be. So there is a shortcut formula for this problem. I will tell you, but first I will give you some time to solve this question and tell me the answer. Yes, Mado. I hope everyone will be able to solve this. But if you want to derive the theory for this question, it will be a little long, but I am just doing the shortcut. So shortcut is, in such cases, dielectric constant, remember this dielectric constant is given by the thickness of the dielectric material. Thickness of the dielectric material divided by thickness minus the distance that you have to increase, in case you want to try to keep the capacitance same. So this is the formula. Sometimes K will be given, you have to find T. Sometimes K will be given, T will be given, you have to find D. Based on the question, this formula, if you remember, you can solve any similar questions. Okay, and this came not super far away. 2021 this question has come, and it is from page number 100, question number 51. Now let's put the value of we are trying to find K anyway, so no matter K only we are trying to find. Thickness is 4 into 10 to the power of minus 3, and once you want to add, the extra distance that you have added is 3.5. Both of them has 10 to the power of minus 3. So I have taken that common. 10 to the power of minus 3, 10 to the power of minus 3 cancels. So you get 4 divided by 0.5, that is equals to 8. So dielectric constant is 8 and dielectric constant is a dimensionless quantity. Okay, so dimension is 8. 7B, Manjunath, Madhavi, Manish, Vinod. Yes, this is the correct answer, option B. Now, next question. 8 drops of mercury of equal radii combined to form a big drop. Okay, the capacitance of a bigger drop as compared to each smaller drop is. So we have 8 small drops of mercury. Okay, 8 such drops, and once you combine them you get a bigger drop, and you want to find what is the how the capacitance changes. Now you have to understand that capacitance for a spherical object is directly proportional to its radius. It's directly proportional to its radius. Okay, capacitance for a spherical object is directly proportional to its radius. Now here assume that small one has radius small r, the big one has a radius capital R. So individually each of them has a capacitance proportional to small r, and this one has a capacitance proportional to capital R. So C dash by C is capital R by small r. So if you can find whatever is the relationship between these two, then you can find the ratio. Okay, now let's see. So 8 are combined, so total volume of 8 small sphere is 8 into 4/3 pi r cube, and that is equals to 4/3 pi capital R cube. This is the total volume of 8 smaller spheres. This is the volume of the larger sphere. So this is how you can calculate. In the end I will tell you one small shortcut as well. So r cube equals to 8 small r cube. So from here we get r equals to 2 small r. So the ratio basically is 2 small r by r, that is equals to 2. So the capacitance will be only 2 times. Even though you have added 8 smaller drops, the capacitance increases only 2 times. Okay, now the shortcut formula is, you have to remember that radius, when multiple spheres are combining to form a larger sphere, okay, the radius formula is n to the power 1/3 into small r. Okay, n is the number of spheres that you are combining. This is the shortcut formula to calculate the relationship between two radiuses. Okay, you can put that and you can calculate it. This is the shortcut formula. If you use this formula, this problem can be solved in less than 20 seconds. Okay, so correct answer option A. Madhavi, I know Madhavi, option B, I think you are answering the previous one. Manjunath, option A. Madhavi, option A. Yes, option A is correct for this question. Now if you want to chat in this video, please subscribe so that you will be able to get access to the chat. Question number 9. An electrician requires a capacitance of 6 microfarad in a circuit across a potential difference of 6.5 kilovolt. So this is the requirement. Okay, 6 microfarad, 1.5 kilovolt. A large number of 2 microfarad capacitors which can withstand a potential difference of not more than 500 volts are available. The minimum number of capacitors required for this purpose is. This is one of my personal favorite question. So how to tackle this question? First of all, your target is to get 6 microfarad and 1.5 kilovolt. It can withstand, but you have 2 microfarad and only 5 volt that it can withstand. So now I will give you some time before solving it. I want to check how many of you can solve it. I will give you some time. I saw someone posted option A and then deleted, but let's see. Manjunath is saying option D. Anyone else? So let's see. So basically, first step to solve this question is to figure out how you can get this voltage rating. Now voltage rating means, suppose you have easier to understand using resistors. So you have resistors, so each of them can withstand suppose V volt. That means when you connect them in series, the overall voltage it can withstand increases to 2 volt, right? So if you want to increase the voltage, you have to connect them in series. Same thing, same logic goes for capacitors as well. So first thing you have to figure it out, how you can make this 2 microfarad 500 volt capacitors into 1.5 kilovolt capacitors. So for that, what you have to do, you have to connect 3 capacitors into series. 3 capacitors into series. Now this can withstand 500, this can withstand 500, and this one can also withstand 500. So total voltage 1500 volt, right? Each of them now can withstand 500, so total voltage this combination can withstand is 1500, and 1500 means 1.5 kilovolt. Okay, 1.5 kilovolt means 1500 volts. Okay, so we have found out how many capacitors we require in series. Okay, this is first step. Now what is the equivalent capacitance of these capacitors? Each of them are connected in series and they have 2 microfarads. So now the equivalent capacitance of one such line is given by 2 by 3. They are connected in series. So connected in series means the total capacitance for line is 2 by 3, equal capacitor. That's why number of capacitor we have divided. Any one capacitance divided by number of capacitors is the capacitance of this particular line. Now, so definitely this is not 6 microfarad, right? This is not resistances, so they do not add directly, it adds reciprocally. So that's why the equivalent capacitance for these 3 is 2 by 3. Now we have n such line. Suppose we connect n such line. In parallel combination, capacitance increases. So we have n such line connected in parallel. Okay. N number of such lines, they are all connected in parallel so that overall capacitance increases. Each of them has 3, so that voltage rating is constant 1500. Now n such capacitors. So now when you connect multiple capacitors in parallel, their voltages gets added, right? Their capacitance gets added. So what is the total capacitance? Total capacitance must be n into 2 by 3. So these 3 capacitors can is equivalent to 2 by 3 now, 2 by 3, and we have similar n number of capacitors in parallel. So total capacitance is n into 2 by 3. Now this must be equals to our required capacitor 6 microfarad. So from there we can say n equals to 6 into 3 divided by 2, which is equals to 9. Now 3 is not the answer, 9 is not the answer. The correct answer is actually 9 lines. Each line contains 3 capacitors. So total number of capacitance is 27. Okay, 3 is not the answer, 9 is not the answer. Correct answer is 27. Okay. Manjunath and Aishwarya answered this question. Rest of the students got fearful about this question, but this is very, very interesting, very intelligent question, and obviously one of my favorite questions from the entire KCET PYQs. Okay, in figure, charge on the capacitor is plotted against potential difference across the capacitor. Okay, in this figure, charge across the capacitor is plotted against potential difference across the capacitor. So charge and voltage are plotted. This is 120, this is 120, this is 10. Okay, the capacitance and energy stored in the capacitor are respectively. So we have to first find the capacitance and then we have to calculate the energy stored. So for 120 microcoulomb, the voltage is 10 volts. So we will first calculate the energy stored can be calculated easily. Energy stored is given by half Q into V. Q is microcoulomb, 120 microcoulomb, that means microcoulomb. Let's keep it as microcoulomb because answer will be in microjoules, and voltage is 10. Okay, so it will be 60. So 600 microjoules. 600 microjoules is the correct energy stored. So if you can see 600, one of them is correct, another one is wrong. Now let's see which one is correct. So how to find the capacitor? Q equals to CV. So C equals to Q by V. Q is 120 again, and voltage is 10. So from here we get 12 microfarad. So correct combination is 10B. Yes, Manjunath, correct answer is option B. Okay, so capacitance is 12, energy stored 600. Next question. Figure shows 3 points A, B and C. Okay, so you see that figure, electric field is shown in this direction, A, B and C. Okay, uniform electric field E. The line AB is perpendicular to BC. So line AB is perpendicular to BC line. Okay, so basically that means this angle is 90 degrees. BC is parallel. BC is parallel to the electric field. Then which of the following holds good? VA, VB and VC represents the electric potential at points A, B and C respectively. So electric potential here is VA, electric potential here is VB, electric potential here is VC. Okay, so which of the following relation is correct? So this obviously is along the same line. That means because they are in the same line, this is an equipotential surface. So VA must be equals to VB. So VA must be equals to VB. So either this or this or this. So one of them is correct. Now which one of them is correct? Okay, let's see. Madhavi also said B. Yes. Manjunath is saying 11D. 11D. Now, so first we have figured this out, that because they are this line AB is perpendicular to the electric field lines, that means it represents an equipotential surface. This is a part of equipotential surface. That means all points on this line must be of same potential. So A and B must be of the same potential. But what about point C? Points, if you see that we are moving in the direction of electric field. So if you move in the direction of electric field, the electric potential decreases. So electric potential decreasing. So that means VA and VB both should be greater than that of C. So VA and VB both should be greater than that of C. That means VA equals to VB is the correct answer. Yes, Madhavi, Manjunath, schools ideas. A, sir. No, not A. Not A. Okay, VA and VB both will be greater than VC. Okay, because if you are moving in the direction of electric field, electric potential decreases. So that means VC must be less than that of VA and VB. So VA, suppose VA is 10, VB will also be 10, VC will be 8. Okay, if you are someone who struggles with the numbers or abstract values, okay, you take any arbitrary numbers in your head, 10, 10, 8. That means 10 is greater than 8. That means VA and equals to VB must be greater than that of VC. So this is also a way to visualize an answer. A dipole of moment P and moment of inertia I is placed in an uniform electric field E. If it is displaced slightly from its stable equilibrium position, the period of oscillation of dipole is. So you have to calculate the period of oscillation. This question came in KCET 2020. Now I will not do the mathematical solution for this, but I will use something which is called tukka. means guess. We will use guess methodology to answer this question, because it is very essential for you to know some guessing method, so that even in case you do not know how to solve this question or some other question, how to solve it. Okay, I have solved this question multiple times in the past. You can go and check that out if you want the exact mathematical solution. But today I am going to tell you a method where you can answer if you know how to guess the correct answer. Only one correct answer is there. First I will check your options. This question 12, Nagaraj is saying option D. Anyone else? Please answer quickly. Aishwarya is saying option D. Now many of you know the answer, okay? If you have solved this question multiple times, you know the answer, but how to guess it correctly? So the guess is, first of all, from the given data, from the given entire thing, you will calculate the omega, okay, omega square value you will calculate. From there you will take the square root of that and you will get the omega value, okay? And time period is given by 2 pi divided by omega. 2 pi divided by omega. So basically, whenever you are seeing any time period related question, okay, if you are seeing any time period related question, there will be a 2 pi outside the square root. It will always be there. All time period related questions, there will be a 2 pi outside the square root. So definitely correct answer is option D. Now if you see a question where frequency is asked, okay, no numerical values, by the way, for numerical values this guessing work will not work, okay? For if you see any question where frequency is asked, for frequency you have to remember all frequency will have a 1 by 2 pi at the end, at the starting point. So this represents frequency, and this represents time period. So this is the correct answer for this question. Yes, Nagaraj, you are correct. Aishwarya, Madhavi, Manjunath, all of you are correct. So we have guessed it mathematically, it can also be shown. So as I mentioned, from the rotational geometry and oscillations and waves chapter concept, as well as electrostatics, you can calculate omega square and then you can find the time period. This is the way. But for this particular problem you don't need to do that, because there is a hint that is given. This is 2 pi. 2 pi represents time period, 1 by 2 pi represents frequency. Now the difference between equivalent capacitances of two identical capacitors connected in parallel to that in series is 6 microfarad. The value of capacitance of each capacitor is. So we have two capacitors, they are connected in parallel. Now this is from page number 100, question number 49. Okay, so the two capacitors, first of all, they are connected in parallel. Each of them have capacitance, say C. Okay, once they are connected in parallel, their equivalent capacitance will be 2C. Parallel means addition. Okay, sometimes in a very speedy way this can create some problem, because this is opposite to that of the resistors. So resistors and capacitors students tend to forget, because we are solving questions from all one chapter, so you might be having that confidence, but you have to replicate that when multiple chapters are combined together, right? So here we have C and C. Now two equal capacitances connected in series, the equivalent capacitance is given by C by 2. So the difference between them is 2C minus C by 2, and that is given here as 6 microfarad. You have to calculate C. Easy. So 4C minus C equals to 12, or 3C equals to 12, or C equals to 4. Okay, C is 4 microfarad. Correct answer is option A. Okay, not option D, Nagaraj. Stay careful. Aishwarya, no, not option D. It will be option A. Okay, not option D. Be careful. So you might think that 6 must be, so addition, the difference between addition and division is 6. So be careful. Take a small amount of time and solve it. Okay. Now next question. I will not tell you the answer, you solve it and then I will say whether it is wrong or right. Okay, a lot of guessing. The figure gives the electric potential V as a function of distance through 4 regions on x-axis, okay, along the 4 regions A, B, C, D. Okay, so 4 regions are shown, the voltage is given like this diagram. Which of the following, this means the voltage is changing like this. So this is the value changing of voltage and this is the distance. Okay, which of the following is true for the magnitude of electric field E in these regions? Now voltage versus distance graph is given and then they are asking you about electric field. So what does that mean? That means we have to use this equation, E equals to dV by dx, or more precisely for this particular problem it will be delta V by delta x. Delta V represents change in potential and delta x represents change in distance. For each region delta x, for this region delta x is 1, for this region delta x is 1, for this region delta x is 2, for this region delta x is again 1. Okay, so delta x also have different values. Now I have given you the hint, this is the magnitude of electric field. You have to answer what is the correct option in this given option, which one are equal, which one are different. Okay, let's see. 14D, Nagaraj is saying 14D. Okay, Manjunath option D, Aishwarya D, Madhavi is also saying D, Yashwant is also saying D. Okay, let's see. So if you see these regions A and C, both regions voltage is, this represents voltage is constant. Okay, so this means voltage is constant in the region A and also in the region C voltage is constant. So constant means what? Constant means delta is 0. Okay, so delta V is 0. So for A and C both regions the delta V is 0, that means EA equals to EC must be equals to 0. So in these two regions electric field is 0 because V is constant. So also we know that differentiation of a constant is 0. So from that logic also you can say EA and EC both are 0. Okay, now what about EB and ED? Now it is about how much V is changing. Okay, delta V represents the change in voltage. Obviously division, if you see the division part delta X, for both cases delta X is 1, 1. Okay, 1 to 2 that means 1, 4 to 5 that is 1. So delta X is constant for both cases. So only delta V determines whether it will be more or less. So if you see that for this B region V is changing from 2 to 4. 2 to 4. So what is the change? 4 minus 2 that is 2. So delta V is 2 for this case. And what about this? It is changing from 4 to 0, that means delta V is 4. That means for D delta V is more and for B delta V is less. That means ED must be greater than EB. Okay, so ED must be greater than EB, so correct answer is option D. EB is less than ED and EA equals to EC. Okay, and both of them are 0. Yes, Madhavi, Yashwant, everyone is correct. Now next question. Two metal plates are separated by 2 centimeters. The potentials of the plates are minus 10 volts and plus 30 volts. The electric field between the two plates is easy question. So as you can see, this used to be a very common style of question in 2019-2018. They have changed it slightly, but still this formula based question you can still expect. So one of them is minus 10 and one of them is 30, minus 10 and plus 30. Okay, so and the distance between them is 2 centimeters. So what is the electric field between the plates? Okay, what is the electric field between the plates? Electric field is from negative to positive, positive to negative, and we will use the same formula, E is equal to minus dV by dx. Okay, if you use delta V formula, minus sign is not required. Anyway, I like to use the negative sign. So minus final point is minus 10, initial point is 30, so minus 30, VA minus VB. Okay, and delta x is 2 centimeter. 2 centimeter means 2 into 10 to the power of minus 2. Don't make any mistake. So even if you are solving it right now in the exam hall, during the pressure, student make mistakes, they forget to convert centimeter to meter and their marks are gone. So don't make that silly mistake. You have to practice. So minus gets common and cancelled with this minus. So you get 10 plus 30 divided by 2 into 10 to the power of minus 2. So 40 by 2 into 10 square. So you get 20. So you get 20 into 100, that is 2000 volts. 2000 volt per meter. Okay, so 2000 volt per meter is the answer. So correct answer is option A. 15A is saying Madhavi, Manjunath is saying option A, Aishwarya is saying option A, Nagaraj is also saying option A. Correct, all of you are correct. Next question. And this one also I will not tell you the answer first, I will see if you are able to answer it. A particle of mass m and charge q is placed at rest in uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y is. This is a very important concept for KCET. Based on this concept, we have seen a lot of questions coming in. Directly, indirectly, this concept is very, very essential. Let's see who can answer this question. So particle of mass small m, charge q, placed at rest in uniform electric field E. So uniform electric field E, a particle is resting. Okay, q charge, mass is m, and you release it. Once you release it, it traveled a distance y. Okay, assuming positive charge, it moves in the direction of electric field. So after it traveled a distance y, what is the kinetic energy? So completely different thing. Electric field is given, charge is given, mass is given, distance is given, and then they are asking you what is the kinetic energy. Okay, Aishwarya is saying 16A. Anyone else? Otherwise I will move on. Nagaraj. Okay, Manjunath is saying 16A. Yes, 16A is the answer, and it will be basically we have to use two things. First of all, work done equals to force into displacement. Force acting on a charge kept in an electric field E is given by Q into E into Y. So this is the work done, and then work energy theorem says that this is the change in kinetic energy. Okay, but initial kinetic energy was 0 because the charge was at rest. So final kinetic energy will be this. Okay, so we have to use two concepts, work done and work energy theorem. Next question. A system of two charges separated by a certain distance apart stores electrical potential energy. If the distance between them is increased, the potential energy of the system may increase or decrease. Increase in any case, remains the same, decrease in any case. This is from the page number 100, question number 46, KCET 2019. So two charges separated by a certain distance stores potential energy. If the distance between them is increased, the potential energy of the system will. Very interesting question. You think twice before answering. Nagaraj is saying A. Nagaraj, which question you are saying A? Last question or this one? Please, if you are answering slightly late, try to mention the question number so that I get an idea which question you are talking about, right? Let's see. So what is the potential energy of system of charges? Two charges separated by a distance. Potential energy is given by K Q1 Q2 by R. Okay, so potential energy is given by K Q1 Q2 by R. So if you increase the distance, what happens to this potential energy? Madhavi is saying option A, Nagaraj is saying option A, Manjunath is also saying option A. Now, why option A? Very important to understand that as well. So, if you increase the distance, it appears that the potential energy should decrease. If you increase the distance, it should appear that potential energy should decrease. That is the mathematics, right? Inversely proportional. So, if you increase the distance, potential should decrease. But that is when both the charges are similar, okay, or like charges. So, if both of them are positive or both of them are negative, in that case, if you increase the distance, the potential energy will decrease. Okay, positive value decreases, right? But if they are unlike charges, one is positive, one is negative, and if you increase the distance, initially suppose the value was -10 and it changes into -8. So, -8 considered to be a bigger number compared to -10. Even though the magnitude is decreasing, because of the opposite nature of the charges, it can increase, it can decrease. If the charges are like, then it will decrease. If the charges are unlike, then it will increase. Okay, so it may increase or decrease depending upon the type of the charges. Okay, now next question. A mass of 1 kg carrying a charge of 2 coulomb is accelerated through a potential of 1 volt. The velocity acquired by it is. So, mass 1 kg, charge 2 coulomb, voltage is 1 volt. So, in that case, we can say that the potential energy of the charge when it is at rest is given by 2 into 1. This is the potential energy, Q into V, right? Potential energy of a charge in a system is Q into V. Okay, that is 2 into 1, that is 2 joules. Okay, now when you accelerate this charge, this much work you have to do to accelerate the charge. So that means the charge is doing an work done of 2 joules, and from work energy theorem, this must be the kinetic energy. So kinetic energy must be equals to half mv square. So 2 equals to half into mass is given 1 kg into v square. Okay, so v square equals to 4 or v equals to 2 meter per second. Okay, so 2 meter per second is the answer. Correct answer is option B. Yes, 18 option B. If the charge is negative, then it is will increase. No sir. Yes, Nagaraj, if the charge, one charge is no. So both the charges are negative, it will not increase. Both the charges negative means minus minus plus. So the denominator is increasing means overall value decreases. If one is positive, one is negative. Okay, we do not know which is positive, which is negative. Any one of them is positive, any one of them is negative. Particular case. So like both charges are positive, both charges are negative, it will decrease always. If they are one of them is positive, one of them is negative, then it will increase always. Okay, so it may increase, may decrease based on the type of the charges. Okay, if both the charges are negative, it will not increase, it will decrease. Okay, so correct answer is 18B. I can see Aishwarya, Madhavi, Manjunath all answered correctly. Next question, question number 19. The work done to move a charge on a equipotential surfaces. I will not answer it. The most easiest question, and it came in KCET 18. Okay, now this question comes in your PU board exam, PU board model papers, right? So this question nowadays is coming in your PU board exam, but it was originally came in KCET exam. Okay, yes, Aishwarya, Yashwant, Madhavi, everyone is saying option D, 0. So work done to move a charge in an equipotential surface is 0 because potential difference is 0. So potential difference 0 means charge into potential difference is the work done. So work done is 0. Now last question for the day, then I will check website. If you know the website, please mention in the chat so that I can check that website. Two capacitors of 3 microfarad and 6 microfarad are connected in series and a potential difference of 900 volt is applied across the combination. They are then disconnected and reconnected in parallel. The potential difference across the combination is, so we have two capacitors, 3 microfarad and 6 microfarad. They are connected in series and you connected them across. This is slightly tricky question. It requires some time. 3 and 6 and 900 volt is the voltage. So you connected them like this. The charge in series combination is constant. So 900 volt is the potential difference. Now you remove the battery, you connected them in parallel. Okay, now they asked you what is the potential difference across the combination. What is the potential difference across the combination? Now there is a shortcut way. Obviously I will going to use the shortcut way as I generally use, but if you try to solve it any other way, it may be a little longer. The shortcut way is nothing but first find the equivalent capacitance of these two capacitors. 3 and 6 are in series, so 3 plus 6, so it will be 18 by 9, that is 2 microfarad. So initially the equivalent capacitance of these two is 2 microfarad. So what is the charge? Charge is Q equals to C into V. The equivalent capacitor will have entire 900 volt across it, right? So what is the charge? Charge must be 2 microfarad into 900 volt. This is the charge. Okay, now when you connected them in parallel, 3 and 6, once you connected them in parallel, what is the equivalent capacitance? Equivalent capacitance now will be 3 plus 6 equals to 9 microfarad, right? 9 microfarad is the equivalent capacitance. Now from the conservation of charge, whatever was the charge for the equivalent capacitor before, the same charge should be there for equivalent capacitance now as well. Okay, so the same charge will continue for the equivalent capacitance now as well. So 9 microfarad into the new voltage that we are trying to find. Okay, so 10 to the power of minus 6, 10 to the power of minus 6 cancels, and we get 9 and 900 cancels, you get 100. So V equals to 200 volts. Okay, so 200 volts is the correct answer for this question. 20C, not D. Manjunath, Aishwarya, Yashwant answered it correctly. Okay, 20C is the answer, not 20D. Okay, so be careful. You have calculated the equivalent capacitance first for the series combination. Next you can calculate the equivalent capacitance for the second combination, and for equivalent capacitance both cases the charges will be constant. Okay, because we are converting them into equivalent circuits, so only one capacitor is there, so each capacitor will have the same charges. Okay, clear? 20 option C is correct, not D. Okay, Manjunath and Aishwarya. Now if you know the website, please let me know. I want to check the if the model papers are out, because I checked today only. If you find the model question paper, please let me know. Okay, it came. Let's see. Okay, it is available. Very good. We will check it and we will make videos as soon as possible based on the model question paper 2025. Okay. Thank you for letting me know that it is available, but it is 24-25. Okay, so model question paper 25 they are saying, but I think it will be 26. So in the DPV website only 2025 is available. Manjunath, not sir, even final exam timetable. Yes, Madhavi, final exam timetable is released, which is provisional one, that is released obviously by this time. During your midterm exam, the final exam timetable, provisional timetable is released. 28th February is this year, but it might change by a day or two. Last year what happens, they initially started on something I think 3rd or 4th of March, but they shifted it to 1st of March. So there is a possibility that 1 or 2 days it might change. That is a provisional date of time of exam. It might change by a day or two. Maybe 28th February can be changed to 1st of March. But otherwise there will be not super number of changes, okay. But if you get the 2026 papers link, for that you can post it in the main chat section of this video. Once this video is over, you will get access the chat of this video. Please paste it, because the question that I am getting over here is 2025, which is last year's paper, not this year. This year is 2026, okay. So if you get the 2026, this is 2024, 2025, okay. This one we have already solved last year. We will do it again if required. If they do not publish anything new, we will solve it as well. But we are waiting for 2026 blueprint. If you get any news on that, if you get where to download it, please share the link in the chat section of this video, okay. This is last year question papers. We have solved all the questions, and in case you need 2026, please share it, okay. No, no sir, yesterday from PU board it came. Madhavi, PU board it came to your college, right? If you get the link directly, ask the teachers if they get the link. If it is available offline, then we have to check it with our respective departments from our Deeksha colleges. I will try to get it from there. Otherwise, if it is available online, definitely we will get it directly, but otherwise I will ask my head of the department and to get me the question paper for the same, okay. Don't worry, if it is available, we will definitely solve it, right. Obviously I would like to end this lecture now. It is almost over 1 hour, okay. So till then, bye, see you in the next class.